awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Assalamualaikum and hi everyone. So welcome back. Jadi dalam video kali ini kita nak buat set soalan yang merangkumi soalan daripada chapter 1, 2 dan 3 sebagai revision. Okey, jadi soalan kali ini formatnya lebih kurang macam final exam awak nanti. So kali ini kita hanya fokus dulu revision untuk chapter 1, 2 dan 3. Okey, so jom kita mula. Alright, so question number 1. So this is about dimensional analysis. So let's read the question first. Work done by gas expansion at constant temperature is given by the equation below. Alright, where P and V is the pressure and volume of gas respectively. Show that the equation is dimensionally homogeneous. Okay, so for this question, we want to prove that the equation given here is dimensionally homogeneous. Alright, so remember, so here we have 2 marks. So in order to show an equation is homogeneous or not, so we need to find what is the dimension of left hand side and also right hand side. Okay, so let's start with the dimension of the left hand side first. Okay, we can write that. Look at here, the yellow color here is the left hand side, while the blue color here is the right hand side. So we have left hand side and right hand side. So we start first with the dimension of the left hand side. Okay, where dimension of W, so this is work, okay, is equal to, so equation of work is F dot S, okay, which is Fs cos theta. So in this case, we just consider Fs, where F is the force, okay, and S is the displacement. Remember the general equation of work. Boleh? Okay. And then, kalau you tak ingat dimension of the force, remember the equation of the force, where force is equal to MA. So we need to expand. Dimension of F is equal to dimension of mass times dimension of acceleration. Okay? And times dimension of displacement. Now, dimension of M, kita dah tahu, it is equal to capital M. Okay. Jadi, bracket yang dimension tadi, let's say here, yang kali biru ni adalah bracket untuk dimension. That means dimension of mass is equal to apa? So, dimension of mass is equal to capital M. Boleh? And then here we have dimension of acceleration. So, kalau kita dah hafal dimension of acceleration is equal to LT negative 2. Okay. And dimension of displacement is L, capital L. So, now we can simplify where M L squared T negative 2. So, this is dimension of the left hand side, iaitu work tadi. Boleh. So, now let's proceed to the right hand side here. Okay. So, the right hand side is the blue color here. So, we want to find what is the dimension. So, as we know that P is pressure, V is volume, and look at here, ln V2 over V1, this we need to consider as constant. Ln V2 over V1 is actually constant. Remember? So, dimension of constant will equal to 1. Okay. So, kita mula dulu dimension of P. Alright. And this is dimension of V. Okay. For that one is for right hand side, right? And the last one is dimension of ln V2 over V1. Okay. So remember that dimension of ln V2 over V1, this is constant. Okay. Ataupun dimension 100, dimension 1000, dimension of pi. Okay. Dimension of any constant will equal to 1. Therefore, we can write as dimension of P, pressure, where pressure is equal to force over area. So, you can write that pressure, okay, dimension of pressure is equal to dimension of force over dimension of the area. And then how about the volume? Okay, dimension of volume tak ada masalah kot kan? And the last one, dimension of lawn tadi, kita boleh je kalau you dah tahu dimension dia adalah 1, dan you darab sahaja dengan 1. Okay, and then dimension of force, remember kalau tak ingat, you boleh expand F equal to MA, okay, over the area times dimension of volume. Okay, so 1 tadi saya tak tulis lah. And then dimension of mass is M, dimension of acceleration is LT negative 2 over dimension of area, apa dia? Tinggi darab lebar, kan? L times L, dimension of area is L squared, and then times the dimension of volume, which is equal to L cube. Boleh? And then, apa yang kita boleh cancel out? Kita cancel out. For example, here we have L squared. Okay, we can cancel L squared and we can cancel this one, and it is equal to 1. Okay, and ada lagi tak? Tak ada kan? So finally, dimension of the right hand side is equal to ML squared T negative 2. Sekarang kita nampak kan? Dimension of the left hand side is equal to dimension of the right hand side. Okay, so we can say that here, since dimension of left hand side is equal to dimension of right hand side, therefore the equation is dimensionally correct. Ataupun kita sebut kat sini dimensionally homogeneous. Alright. Okay, jadi kalau kita cari dimension left hand side and then tak sama dengan dimension of right hand side, so jawapannya the equation is not dimensionally homogeneous. Okay, kita dah selesai soalan nombor 1. Ingat ya, soalan nombor 1 lebih kurang 2 markah. So, make sure you cuba untuk dapatkan markah tersebut. Boleh? Okay, jom proceed kepada soalan yang kedua. Alright, so for question number 2, so here we have 2A and this is 6 marks. And we have another one which is 2B, which is 4 marks. And the total marks for question number 2 is 10 marks. Alright? So please focus on chapter 2 since this chapter will contribute 10 marks. Okay, lebih kurang lah 10 marks in your final exam. So now let's read the question first. Here we have a graph of acceleration time of a car which starts from rest is shown in figure 1 below. So here we have graph A against T, and number 1, calculate the velocities of the car at 10 seconds and 20 seconds. Okay, so macam mana kita nak kira? Bila kita ada graph A against T, macam mana kita nak kira velocity of the car at 10 seconds and also 20 seconds. Jadi daripada graf yang kita nampak dekat sini, at t is equal to 10 second, the value of the acceleration is equal to 4. Okay, dia dah bagi. And then soalan dah bagi tahu kan, okay, car tu mulanya daripada rest. Okay, so here we have the information about u, where it is equal to 0 meter per second. Alright, so we start question number 1 here. Okay, so we can use equation. Actually, we can use equation, at t is equal to 10 second. So we can use equation v is equal to u plus at in order to find what is the velocity of the car at t is equal to 10 seconds. Okay, therefore v is equal to u is 0 plus acceleration at t is equal to 10 seconds. So we can see here at 10 seconds the acceleration is equal to 4. Okay, and T is 10. So V at 10 seconds is equal to 40 meter per second. Okay, so this is the answer. And then we want to find what is the velocity at t is equal to 20 seconds. So at t is equal to 20 seconds, so same as before, we can use equation v is equal to u plus at. Okay, so kali ini u kita bukan kosong, u kita kali ini adalah 40. Sebab apa? Kita tahu tadi at t equal to 10 seconds, v dia adalah 40 meter per second. Therefore, kita nak kira lah masa dekat sini. Kan kat 20 second tu, berapa dia punya V. So, kita masukkan U kita. Okay, U kita adalah 40. Plus, the acceleration here. Okay, the acceleration is equal to negative 4. Since here, 20 seconds, the acceleration is negative 4. Okay, so negative 4 times 20. Therefore, at point 20 seconds, okay, the velocity is equal to, berapa tu? 40. Oh, okay, kita tersilap dekat sini kan? The time is not 20 second. So, maknanya time tu kita, sebab kita ambil U daripada 10 second. So, time tu we must consider from 20 to 10. So, from 20 to 10 means that the duration of the time is not 20 seconds, but 10 seconds. Alright, so here we should put 10. Sorry. Okay, so here we should put 10. Therefore, V is equal to 0 meter per second. Masa 20 second tu, V dia adalah kosong. Boleh? Okay. So, finish number 1, A1. And then sketch the velocity time graph for the whole journey. Labels the values of velocities at 20, 10, 20 and 30 seconds. Okay. So, now before we start for question number 2, okay, we want to sketch the graph, right? So, means that we need to calculate what is the velocity at t is equal to 30 seconds. Sama juga macam tadi, kan kita akan guna formula V, U plus AT. So, kalau kita nak gunakan, tengok dekat sini ya, kalau kita nak ambil U ini daripada 20 second, so maknanya daripada sinilah. Sekejap saya tunjukkan. Daripada sini. Kalau kita ambil U daripada sini, U at 20 seconds means that the duration is 10 second. 20 to 30. Okay. So, dia akan jadi V is equal to U which is 0. At 20 second tadi kita dah kira 0. Plus the acceleration is negative 4 masa 30 seconds. And then T is equal to 10. Therefore, V is equal to negative 40 meter per second. Kita perlukan semua maklumat ni sebab kita nak sketch our graph. Okay, VT graph. Alright, so now let's sketch the graph. So here we have V. Okay, the unit is meter per second. And then we're going to have, okay, so here let's say we have T in seconds, start from 0. So here we need to label. Okay, 10 seconds, 20 seconds, and then 30 seconds. And the velocity we have 0, 40, and negative 40. Alright, so now look at here. Okay, at 10 seconds, okay, the velocity is 40 here. Okay, so we just sketch here. Okay, so start from 0. Okay, start from 0, increase until, kenapa, macam mana saya tahu dia increase? Sebab from 0 to 10 second, dia ada acceleration yang constant. Look at here, the acceleration is constant which is 4. That means the graph of VT graph from 0 to 10 seconds must be a straight line graph. Okay, so here, from 0 to 10, so this is the straight line graph. And then from 10 to 20 seconds, okay, 20 tu kita dah tahu kan, dia adalah 0 tadi. The velocity is 0. And then at 30 seconds, the velocity is -4. Okay, so kalau kita sambungkan, kalau kita nampak tu, kan, dia mesti turun ke bawah macam ini. Sambung. Boleh? Dah siap kita punya graph. Okay, so finish number 2. Determine the total distance. Remember, the total distance ataupun total displacement. Baca soalan betul-betul. So, kali ini kita nak kira total distance. Means that we need to calculate the area under the graph, and then bila you calculate area under the graph, you need to ignore the negative sign of the velocity. Ignore direction. Sebab negative sign of the velocity adalah direction, right? Okay, so in this case, if we calculate the area under the graph, so let's say we have the blue color here. Okay, so this is the blue color. The area under the graph here is positive. Yang color biru ni, area under the graph dia adalah positive. But if we proceed to the second part here, the yellow color here, the area is negative. Bila you kira total displacement, okay, mesti consider negative area here. Sebab ada negative sign here, right? So, the positive value here plus negative value here. Itu hanya untuk total displacement. Tapi, bila kita nak kira total distance, we ignore the value of negative here. Therefore, so let's calculate here. The total distance, okay, which is equal to the area under the graph, it is equal to, kita kira dulu yang biru lah, half, it is a triangle, right? Times 20, the base and also the height of the triangle. Okay, so this is the blue part. Okay, and then plus, we have the yellow part, which is half times 30 minus 20 is 10. And the height is 40. Kita tak ambil negative 40. Ingat ya. Total distance. Therefore, this one we can cancel out. Okay. So, same goes to this one. And then, kita akan ada 400 plus this one is 200. Therefore, the answer is 600 meter. Unit jangan tertinggal. Okay. So, finish 2A, 6 markah dekat sini. So, kita bergerak kepada 2B. Okay, so here we have 4 marks and this is about projectile motion. Okay, alright, so let's read the question first. Okay, so a long jump athlete take off at 25 degree with the horizontal and achieve a jumping distance of 9.12 meter. So the value here, 9.12 meter is the horizontal displacement Sx. Alright. And the angle is 25 degree with the horizontal. So ada angle lah. Tapi dia tak bagi berapa dia punya initial velocity U. So calculate the initial takeoff speed. Okay. So sekarang kita nak lukis sikit. Contohlah kita ada, macam ni lah gambar kita. Okay, so this is U, for example. So the angle is 25 degree to the horizontal. So this is the angle. Okay, so bila dia lompat naik atas sampai turun kat sini. So sampai sini. So soalan kata apa? Soalan bagi tahu, okay, the distance ataupun jumping distance tadi Sx dia adalah 9.12 meter. 9.12 meter. Persoalannya dekat sini kita nak kira U. Okey. Jadi hanya ada maklumat Sx. Untuk dapatkan U, sebenarnya kita perlu ada Ux dan juga Uy. Betul tak? Okey. Kalau kita nak kira U, kita kena ada Ux dan Uy. Tapi Ux pun kita tak ada lah. So kita tulis dulu. So if we resolve U into X and Y component here, so Ux will equal to U cos 25. Okay, pastikan U mahir resolve vector. Dan Uy is equal to U sin 25. Okay, so in this case here, Okay, so we can write first that Sx equal to Uxt. So from this equation, actually we can find what is Ux. Okay, kita cuba. Okay, so Sx kita ada tak? So dekat situ kita ada lah. 9.12. Tapi Ux kita tak ada. Kita boleh masukkan U cos 25T. Kita tak boleh selesaikan sebab ada dua unknown. Kita ada U yang kita tak tahu dan juga kita ada T yang kita tak tahu juga. So, kita biarkan sebagai equation number 1. And then equation number 2. So, dalam case projectile motion ni, kita ada nilai Sx dibagi dalam soalan. 9.12 meter. Tapi kita lupa yang sebenarnya kita tahu juga nilai Sy. Kenapa? Sebab the object is start from here. Okay, dia lompat and then dia kembali kepada sini. Jadi, kalau dia naik ke atas, contohlah, daripada sini sampai maximum height, contohlah, berapa? 10 meter. Positif 10 meter sebab naik ke atas. And then dia daripada atas turun pula ke bawah. Tambah negatif 10 meter. So, the vertical displacement of the motion is actually equal to 0. Okay, so ini konsep yang you kena faham. 0 meter. Okay, Sy equal to 0 meter. So, bila kita tahu sebenarnya kita ada satu lagi maklumat iaitu Sy. So, now we can write that Sy is equal to Uyt minus half gt squared. And then, this is the equation of vertical displacement. Okay. Walaupun soalan hanya bagi kita Sx, tapi kita jangan lupa kita sebenarnya ada maklumat Sy. Okay. So now, since Sy equal to 0, Uy kita tak tahu, tapi kita boleh masukkan U sin 25T minus half G tu, kalau nak ganti, bolehlah ganti 9.81 T squared. Okay. So, daripada sini, kalau kita rearrange the position, okay, saya sambung sebelah. So, kita akan dapat 9.81. Okay. So, dia akan jadi half 9.81 T squared is equal to U sin 25T. So, T ni kita boleh cancel. Kiri kanan ada T, so kita boleh cancel T kan. Therefore, if we try to solve the equation, we can find the value of T in terms of U, which is T is equal to 0. Ini kita nak susun kan? Kalau nak susun boleh juga. Dia akan jadi T is equal to 2U sin 25 over 9.81. So, T is equal to 0.0862U. Okay. Masih tak boleh selesaikan lah. Masih tak boleh selesaikan. Okay, so kita dah dapat T. Kita tulislah ini number 2. Therefore, okay, we can substitute. Okay, equation number 2 into equation number 1. Okay, kita masukkan T tu dalam equation number 1 lah. So, equation number 1 kita tulis balik. U kita tak tahu. Cos 25 times T, 0.0862U. Kita tulis macam tu. So, yang ni kita dah boleh selesaikan lah. Okay, cos 25, which is 0.9063U times 0.0862U. Kita selesaikan. Akhirnya, you akan dapat U is equal to 10.81 meter per second. So, this is the answer. Okay. And then, calculate the maximum height of the jump. So, we want to calculate the maximum height. And remember, okay, at maximum height dia kat mana? Sini. Kan, dari sini. Kan. So, at this point, remember, at this point, okay, Vy is equal to 0. At maximum height, Vy is equal to 0. Bukan Vx tetapi Vy. Okay. So, kita tulis dekat sini. At maximum height, okay, Vy is equal to 0. Therefore, okay, we can actually calculate Vy. We can use Vy squared equal to Uy squared minus 2G Sy. Sy itu adalah apa? Sy ni apa dia? Sy ni ketinggian inilah. Sekejap ya. Saya tunjuk. Sy itu inilah dia punya Sy. Start from here, we have Uy. Okay, sebab kita dah dapat U tadi, you can find Uy. Start from here. Kalau you guna Y saja, Y equation Y. So, semua you kena guna Y. Tak boleh lah you nak cari. You ada Vy dekat sini. Uy ni you masukkan Ux. Tak boleh. So, start from here. Moving until reach the maximum height. So, from the ground, this is Sy. Okay. Sy here is the maximum height. Ataupun you boleh tulis capital H. Okay. So, maximum height here. So, Vy is 0. Uy is U sin 25. Remember. Tolak 2G. Sy itu adalah maximum height dia lah. Saya tukar kepada capital H. Therefore, you can find what is the maximum height. U kita dah cari tadi. 10.81 meter per second. Sin 25. Okay. And then you can find H lah. H is equal to 1.06 meter. Alright, so finish question number 2. Let's proceed to question number 3. Alright, question number 3. So, for your information, markah untuk question number 3. So, kita ada lebih kurang 14 markah. So, here we have 3A, 2 marks. And then we have another question, 3B, 7 marks. And then the last one is 3C, which is 5 marks. Okay, so jom kita cuba test diri kita. Boleh ke kita jawab soalan chapter 1, 2 dan 3? So, jom kita mula untuk soalan nombor 3. Kita baca dulu soalan. Alright, so here we have a water rocket is specially constructed so that it able to has total impulse of 29 Newton second. Alright, so the mass of the rocket is 0.175 kg. What is the speed that this rocket achieve when launched from rest? So neglect the effect of gravity and air. So here, so soalan bagi kita impulse J, is equal to 29 Newton second. And the mass of the rocket is 0.175 kg. Okay, ni macam roket air yang awak buat tu lah. Lepas tu, okay, kita nak kira apa tu? Kita nak kira speed of the rocket bila dia launched from rest. So, means that U is equal to 0. So, from here, we want to find the speed, which is V. So, we can straightly use formula of impulse. Okay, is equal to the change of momentum, which is momentum final minus momentum initial. So, since the impulse is equal to the change of momentum, therefore, J is equal to mv minus mu. So, jadi U kita kosong. So, sini akan jadi kosong lah. Okay. So, masukkan nilai 29 here. The mass is 0.175. So, V kita nak cari. Therefore, dua markah V is equal to 165.71 meter per second. Okay. So, this is the answer. Alright, question B. We have two cars, 1 and 2. Okay, so the first one and this is the second car. Okay, approaching each other along two different streets that meet at a right angle collider at the intersection as shown in figure 2 here. After the crash, they entangle, stick together. Okay, if one car has a mass of this and initial speed of this, and the other has a mass of this and the initial speed of this. Okay, what will be their speed? Okay, sebab dia stick together after collision. Okay, we want to calculate what is the V final and also the direction immediately after the impact. Okay, so let's start. Okay, since this is 2D collision, conservation of momentum. Kalau you tengok dekat sini, kereta number 1 bergerak ke kanan, iaitu in X component. While the second car is moving upward, which is in vertical direction or vertical component. Jadi bila kita nak kira by using conservation of momentum, so momentum initial equal to momentum final, right? But we need to consider two parts, which is x component and also y component. Okay, so if you want to calculate, okay, by using conservation of momentum in x component, kita tulis kat situ x. Okay, P final x. Ini penting. Okay, banyak kali saya pesan, this is very important. You must state that this is about x component. Jadi bila x component, kita tengok apa nilai yang ada dekat x component, bukan y component. Okay, jadi sekarang before collision, kedua-dua objek bergerak. Yes, kedua-dua objek bergerak. Dan kedua-dua objek ada momentum dia. But the first car is moving in x component, which is to the right. Therefore, before collision, the initial momentum hanya ada pada kereta yang pertama. Kereta yang kedua tak ada. Sebab dia bergerak in y component. So, ini hanya ada nilai and initial momentum ini in x component tak ada. So, dia adalah kosong. So, jadi bila kita tulis, dia akan jadi M1 U1X. Betul lah kereta tadi U1, dia memang bergerak in x component. Kan? Plus 0. Okay, sebab kereta yang kedua, dia tak ada U2X. Dia tak ada U2X. Dekat sini dia hanya ada U2Y. And this is U1X. Okay. Sebab itu saya letak kosong terus. But after collision, since they are stick together, okay, so M1 plus M2, the mass must be combined together. Okay. But final momentum kan sama juga. P equal to MV. So V dia tu kita kena letak V final, which is in X component. V lah. V tu memang dah final. Velocity kita letak saja X. Vx. Boleh? Okay, sekarang kita nak cari V final. Tapi untuk kita cari V final ini, tolong ingatlah, kita nak cari V final ni, kita perlu ada Vx squared dan juga Vy squared. Baru kita boleh dapat the resultant value of the final velocity. So now for M1, saya akan masukkan 1450 and then U1X. U1X is moving to the right, so it should be positive. Okay, remember kalau to the left, negative lah. Okay, so 11.5 equal to M1 plus M2. So M1 is 1450 plus 1750 Vx. So from this calculation, we can find Vx 5.21 meter per second. So finish for X component. And then we move to the Y component. Okay. Sama juga. Kalau diperhatikan, saya akan letak Fy. Total momentum initial Y equal to total momentum final Y. Ini untuk Y pula. Okay. So, kali ini terbalik. Okay, in Y component, kereta X tidak ada initial momentum. Dia tidak bergerak in Y component. Only second car is moving in Y component, which is upward direction. Okay, so 0 plus M2 U2Y equal to, they are combined together, right? So the mass must be combined. And then here we're going to have Vy. So we substitute all the values. 1750 for the mass of the second car, and then the initial speed is 15.5. Okay, it's equal to, so here we need to combine the masses of two cars. Okay, and here is Vy. Okay, so Vy is equal to 8.48 meter per second. Therefore, we can calculate V final, where V final is equal to square root Vx squared plus Vy squared. Okay, so kita dapatlah jawapan yang dia tanya tadi, iaitu berapa tu? Sekejap. Saya cari dulu jawapannya. Sekejap ya. Okay, kat sini saya dapat 9.95 meter per second. Okay, so this is the answer for V. But remember direction theta. Jangan lupa untuk kita kira theta is equal to inverse tangent Vy over Vx. Okay, masukkanlah nilainya. Okay, and then you akan dapat, okay, the angle is equal to 58.4 degree. Above ke below? Mestilah above positive x-axis. Gambar pun dia dah bagi kan. Okay, kat sini above positive x-axis theta 58.4 degree. So this is the answer. And then second, what is the type of this collision? Apa jenis collision ni? So in order to determine the type of the collision, we need to calculate what is the total initial kinetic energy and what is the total final kinetic energy. Okay, so kita kira dulu lah total kinetic energy initial half m1 u1 squared. So since both car are moving, okay, initially, so means that kinetic energy car1 kena tambahkan dengan kinetic energy car2. Remember, energy tu bukanlah vector, tetapi dia adalah scalar. Okay, so dia tak perlu consider x component ataupun y component. So kita boleh tambah terus half m1 u1 squared plus half m2 u2 squared. So from here, we can calculate what is the total initial kinetic energy. Okay, so here we have 15.5 squared. Okay, so the answer is 3.06 exponent 5 joule. Alright, and then the total kinetic energy, final, okay, is equal to K final half m1 v squared, okay, plus half m2 v squared. Kan, so since the velocity sama, sebab dia bergerak sekali ni, v ni sama yang saya highlight dengan warna biru ni. So, bolehlah half tu boleh factorize kan, m1 plus m2. Okay. And then v squared. Okay, kita boleh buatlah darab dengan v squared. V dia tadi berapa? 9.95 squared. Mass dia sajalah yang kita tambah. Mass 1 plus mass 2. So, nanti you akan dapat 1.58. Ini yang saya kira lah, you check Okay, therefore, so since total kinetic energy initial is not equal to total kinetic energy final, therefore, okay, this is inelastic collision. This is inelastic collision. Okay, so this is the answer. So finish for 3B. Okay, and then we proceed to 3C, the last question for this video. Okay, so here we have 5 marks. So now let's read the question. A student tried to pull up a wooden boat of mass 80 kg along the inclined track, which is 150. Sorry, this one should be 15 degree, which is 15 degree, okay, 15 degree above horizontal as shown in the figure. If the coefficient of static friction between the boat and the track is given, what is the minimum mass of water supposed to be added here into the bucket so that the boat is just about to move? Okay, so kita tambah air sampai satu masa boat ni akan mula bergerak naik ke atas. So, berapa agak-agak sini mass yang kat sini lah. Okay, so maknanya kita kena consider kereta tu akan mula bergerak lah. Maknanya just about to move, tapi kita tak bolehlah tahu dia punya acceleration berapa. So untuk case ini, first kali kita lukislah dulu kita punya free body diagram. So on the bucket here, so we're going to have the mass. Okay, it should be the mass of the water. Okay, sebab dia kata kat sini neglect the mass of the bucket. So W here should be the weight of the water lah. And then here we're going to have tension. So, jadi kalau soalan bagi the mass of the bucket, awak hanya nak cari the mass of the water. Jadi, nanti kena tolakkan lah mass yang kita kira tolak dengan mass of water. Tapi sebab kat sini dia kata abaikan saja the mass of the bucket. So we need to consider the whole mass here. Okay, the whole mass here is the mass of the water lah, which is the weight of the water. Okay, and then for here we have tension. And then this is the y-axis. And this is the x-axis. So kita akan ada juga friction, opposite direction. Kita akan ada normal force. And then weight kita straightly downward. Itu masalah ni. Sekejap kita ambil warna lain. Okay, the weight is straightly downward. Okay, so the angle here, yang kali hijau ni, ini 15 degree lah. Boleh? Okay, so kalau kita, kalau soalan memang minta kita, okay, lukis free body diagram, okay, pastikan you tak pusingkan x-axis and also the y-axis. This one should be x-axis. Alamak, saya ingat pula. And the y-axis must be perpendicular to the surface. Okay. So, dia akan jadi. Here is T. Normal. Friction. And then weight straightly downward. So, angle here must be okay, 25 degree. Sorry. That one is 15. 15 degree. Okay. Okay. So, untuk mass 1, untuk water tu tak ada masalah lah. Water ada 2 saja. Weight of the water. And then the tension. Okay. So, saya akan lukis lah. Dia akan bergerak ke bawah macam inilah kan sepatutnya. Tapi sebab dia kata it's about to move. Okay, acceleration dia kita kena consider masih kosong lah. It's about to move. Okay, so jadi for mass 1, okay, mass 1 tu kita akan letak dia sebagai here the weight of the wooden boat. Tak boat lah sini. Okay, so boat untuk mass of the boat. So, free body diagram dia kita dah lukis tadi lah. Jadi, untuk memudahkan kita, bila kita nak buat calculation, boleh you nak pusingkan. Tapi, kalau soalan memang minta free body diagram, you jangan rotate. Ingat ya. Jadi, kalau you nak rotate untuk you punya calculation, tak ada masalah lah. So, dia akan jadi macam ni. Y, X. Kalau nak kata Y dia, ada normal, akan ada weight. So, here should be 15. So, here is T. And this is the friction. Okay. So, the motion in this direction lah. Okay. So, W you can resolve into WY. Okay. Or WX. Okay. I should use another color here. Yang ni pula dia turun ke bawah lah. Okay. So, look at the motion is in X component. So, we can write total Fx. Kita nak cari apa sebenarnya ni? Kita nak cari mass kan? Mass of the water. Okay. Jadi, bila kita nak kira mass of the water, kita kena cari the weight of the water. So, in this case, bila kita nak buat, okay, saya pindah ke sini sikit ni. Sekejap Allah. Sekejap. Okay, saya pindah kat sini. Okay, this is the mass of the water. Okay, so kita akan buat total Fy equal to 0 for the water. And it is W ataupun T plus, bagi kita equal to 0 kan? Negative W equal to 0. Okay, ataupun W plus negative T pun boleh juga. Sebab nak ikut motion kan, W plus negative T boleh juga. So, daripada sini kita boleh kira the weight, which is the mass of the water times gravity equal to tension. So, untuk cari the mass of the water, you perlukan nilai tension. Kan, tension over gravity. So, kita tak boleh selesaikan. We need to let this as equation number 1. So, that's why we need to move to another part, which is the mass of the boat. Okay, we need to draw the free body diagram and then take out the and then construct the equation of total fx and also total fy. Okay, so let's start here. So the boat is moving in this direction. Tapi sebab dia kata just about to move, so we still can consider that the total force in x component is equal to 0. Okay, sebab it's about to move. So V dia masih kosong, A dia kosong lah. Okay, so dia akan jadi, look at here. Okay, so the motion in this direction to the right. So T plus negative friction, which is opposite direction dengan motion. Friction kan, mestilah opposite direction dengan motion. And then we have another one. Jangan lupa weight dia. Okay, dia nak naik atas, dia mesti lawan juga dia punya weight dia lah in x component. Plus negative Wx. So dia akan jadi T plus negative friction plus negative Wx equal to 0. So from here, we actually can find what is the value of the tension. So Wx dia akan jadi mg sin 15. Okay. So nak cari T ni pun bukan mudah lah. Okay. Kita kena cari pula. Mu dia dah bagi. Okay. Frictional force dia tak bagi kan. Tapi coefficient of frictional force dia bagi. Mu. Okay. Kat sini kita ada normal force. So tanya dirawak. Normal force tu duduk dekat mana? Normal force duduk dekat y component. So total Fy equal to 0 pula. Untuk kita cari N nanti. Okay. Ini masih tak boleh selesaikan equation number 2. Okay. So, in Y component, we just have two forces here. N upward, WY downward. Straightly, you can write N plus negative WY equal to 0. So, N kita akan dapat teruslah mg cos 15 degree. And this is equation number 3. Therefore, tapi you nak kira, boleh tak kira N terus? Boleh juga. Okay, kita cari N. So, N terus dapat lah. Okay, the mass of the boat is 8T times 9.81. Okay, cos 15 degree. So, N dekat situ saya akan dapat 758.06 Newton. Boleh? So, from here, okay, we can write therefore tension, okay, from equation number 2, we can get tension is equal to mu N. Mu dia dah bagi dah. 0.2. Darab dengan N. Okay. Plus mg sin 15 degree. Okay. So daripada sini you akan dapat tension which is 354.73 Newton. Boleh? Dah dapat ni, selesaikan je lah kat sini. Therefore, the mass of the water is equal to tension over the gravitational acceleration. Okay? So, kat sini saya dapat jawapannya 36.16 kg. Okay? So, jawapan ni menarik. Soalan ni menarik, bukan jawapan menarik. Soalan ni yang menarik. Alright. So, we finish all the questions. Okay? So, make sure you revise dan study semula chapter 1, 2 dan 3. Okay, kini walaupun sekarang you dah sampai chapter 7 ataupun chapter 8, jangan lupa untuk you buat revision awal sebelum menjelang final exam. Itu saja untuk video kali ini. Dalam video seterusnya, kita akan discuss soalan-soalan berkaitan dengan chapter 7. Jumpa lagi. Assalamualaikum. Bye-bye.